Good morning, guys. In this video we are looking at the test questions from CAT 008. In this test we had the following questions. The first question was on transformation, describing transformation generally. Question 2 was on quadratic equations and graphs. Question 3 was again on transformation, basically graphing the effects of a transformation. Question 4 was on logarithms, basically the laws of logarithms. Question 5 was on financial math, basically GP with compound interest. Question 6 was sequences and series, specifically arithmetic progressions, APs. Question 7 was the last question, and this was on coordinate geometry, the equation of perpendicular and parallel lines. At the end of the video, I will also try to, go back and briefly look at consolidate on transformations. And if there is time, I will also do some bit on a summary of financial mathematics. Okay. All right. So here is question 1 on transformation. In this particular question, we were looking at reflection and translation. The question covered only 2 areas of transformation. Here is the first question. You are given a function, y is f of x. You have some special points there, crosses the y-axis at 0, 4, passes through the point A24, and crosses the x-axis at 3, 0. Point A has that coordinate, each graph. So in each graph below, you're asked to show single transformation of the function f of x. Okay, so part A of the question was describe fully the transformation that maps, this is our original graph, that turns it into this. Okay, so we can see the original point A, which was 2, 4, has moved to 0, 4, and 0, 4 has moved to negative 2, 4. Okay, and the original point 3, 0 has moved to 2, 0. So clearly this is a translation in that direction, negative x direction. So how many steps has the graph moved? We can see, we can just pick one point and we see that this point has moved 2 steps in that direction. So we could say that this is a translation of vector. So first of all, it's a horizontal translation, gives you a mark, and that it has a vector negative 2, 0, because we are moving in the negative x direction. Yeah. The second one, here is the original function, and it becomes this. So if we look at this carefully, the x-axis has remained invariant. Okay, so that point has not changed. 3, 0, and 3, 0 there has not changed. 2, the point that was at 4 has moved to 2. The y-axis at 4 has also moved to 2 there. So clearly this is a stretch, if you like, or a compression. Basically, in the IB, we prefer to say a dilation of scale factor half. Okay, so description, we refer to this as a full description. A vertical dilation or compression, that's 1 mark, and you state the stretch factor of being a half. So the graph has compressed to half its original height for values of y. The last one, all right, the y-axis has remained invariant, so this point stays the same, as you can see on the y-axis, but point A has now gone to the opposite side, to somewhere there, okay, to negative 2, 4. The base, or the 0 of the function, 3, 0, has moved to negative 3, 0. So clearly this was a reflection in the y-axis, as the IB likes to say. In the British curriculum, they prefer to say about the y-axis. So this is a reflection in the y-axis. Okay. Question 2 was quadratic function, intercept vertex form, and I think there was a factor form also in there. The graph on the side shows the quadratic curve. G of x equals a into x minus p, x minus q. The curve crosses the x-axis at 1, 0, and 5, 0. These are called the zeros of the function. And it also crosses the y-axis at 5, 0. That's the y-intercept. The axis of symmetry has the equation x equals r. There is the function. Move out slightly. Write down the value of p and the value of q, hence find the value of a. Write down the value of r, that means the equation of the axis of symmetry there. We want to know the value of r there. Then we are told the function g of x can also be expressed in the form, that is the vertex form, where h and k are of course the coordinates of the vertex. Find the values of h and k. Then the last part is the function g of x is the result of a transformation of the function x squared. F of x is x squared. Describe fully the transformations, it could be one, could be more, that maps f of x onto g of x. So let's start answering this question. Here, that's the graph again. Write down the value of p and the value of q. This should be easy. If we are given the function there in factor form, the first expression up there, basically we are given that y or f of x or g of x was equal to a into x minus p into x minus q. Then directly we can see the value of p and the value of q are in fact the zeros of the function, the values of x at where the graph crosses the x-axis. So clearly we should be able to see there that one of the values has to be 1 and the other value has to be 5. Yeah, I might need to erase. Right, so p and q are the x-intercepts, also known as the zeros of the function, and therefore p has to be 1 and q has to be 5. Okay, part B, hence find the value of a, or in that function that we wrote down. If we are going to find, I'll write it here again so that we see what we are doing. Y was a x minus p x minus q, but we've determined this is 1 and this is 5, so we should be writing it like that. And so if we are looking for the value of a, then we can make use of the y-intercept there, substitute values of x and y into the function. So y is 5 there and x is 0. If we substitute that, we should be able to find the value of a directly. So 5 equals minus 1 times minus 5 from here. X is 0. And that should tell us that 5 is, because this here, this is 5 equals a into negative 1 into negative 5. 5 equals 5a. Negative times negative is positive, so clearly a is going to be 1 there. Probably have to erase that quickly. Okay, so a is 1. Part C, r is the axis of is the x-coordinate of the axis of symmetry, so it's the value of x right there. When we are given the equation in factor form, it is quite straightforward to get the value of r. We find it by taking p plus q, which are the values of x there, and then we divide by 2 because the graph is symmetrical about this point. So this point has to be right in the middle between point 1 and 5. Excuse me. And that gives us a value of 3. So the equation for the axis of symmetry is x equals 3. The value of r is 3. The next part of the question 2, the function can also be expressed in the form a into x minus h. So basically in vertex form, find the value of h and the value of k. We've already done the bulk of the work. We know the value of a, we know the value of p and q. So we could, so this is the function once we substitute the information we had from the previous part. If we substitute the x-coordinate of the vertex, the x-coordinate is 3 that we just found earlier. So in place of x, we put the x-coordinate to find the value of y at the vertex. So substituting 3 there, and we get y is, or f of x is 3 minus 1, 3 minus 5. That is going to be 4 because that is positive 2. And that is negative 2, so the y value is going to be negative 4. So the coordinates of this point is going to be 3 minus 4. Hence, g of x can now be expressed as, since we know that 3 there, that 3 is the x-axis, which is the value of h there, and minus 4 is the value of k. And so that's how we write the equation in the vertex form. I think this is the last part. The function g of x is the result of the transformation of the function f of x is x squared. Okay, so basically the function has moved from this point here. This function was here, like that. Okay, and it has shifted down to this point. So the original vertex has moved this way and then down to that point. So what is that transformation? Okay, so what transformation is that? How do we reason? If we know the function in the vertex form, that is quite straightforward. So f of x has become g of x, meaning x squared has become x minus 3 squared. That's the bracket, and the square is the original function. Now we have changed x to x minus 3, and we've also subtracted 4 from the function. So based on our discussion, this would have to be a translation. Okay, it is a translation with a vector equal to 3 because the graph has moved into the positive direction. It is 3 and down minus 4. Question 3 is on transformation, reflection, and translation. So here is a function. We are given a graph in this case. Usually in such question you're asked to sketch the resulting function after a particular transformation. So here is part A, the function y. So our original function, y is f of x, is becoming y is f of negative x. We have seen that this is a reflection in the y-axis. That means a horizontal flip. But how do we actually do this for the IB? If we are answering this question for the IB, the best thing to do is to create the coordinate set for f of x for a few points whose coordinates you know. So part of this must be the last point there, you can approximate it, and the last point on this side. So the end points must be included in the scale, in the coordinate set that you prepare. So we set up an ordered pair, x and y coordinates for f of x, and we do the same for the transformed function. So we will put for coordinates of f of x, and we will also put the coordinates for f of minus x. So for f of x, we pick a few points. So other than the endpoints, we also pick, like that point there, we are sure of the value. We are sure of the values of this point here. We are sure of that vertex up there. We are sure of the y-intercept, and we will take that endpoint. So we'll take that point. The coordinate is minus 3, 0. If we reflect that, we should get 3, 0, because whatever the value of x was, it becomes negative of itself, right? The next point there is minus 2, 3. So the y-coordinate does not change. This transformation affects only the x value. So that value there is negative 2, must become positive 2. The next point is negative 1, 4, which now becomes 1, 4, and so on and so forth. If we plot all the points, so now the endpoints, and I'm marking the endpoints with a filled-in dot. Okay, and the last one there has coordinates as given. Okay, so now our job is to sketch the blue side. Okay, the coordinates of f of minus x, and so when I plot them in, that is the reflection of this endpoint, must be that. The y-intercept remains invariant. The other point there, minus 1, 4 becomes 1, 4, and so on and so forth. And when we plot this, I didn't give enough space for this, for this graph. So basically, you just move it a little there out of the graph. In a real exam question, of course, there will be space to do this. And then all you do is join the point, and that is the reflection or the function or the graph of the function y is f of minus x. Okay. Part B. All right. This time we want the transformation is a half of f of x. So this is a transformation occurring the y-axis, because a half is multiplying f, the function itself, or y. So whatever was y becomes a half y. So the x direction remains invariant. The y-axis becomes half of what it was. And if we do the same thing that we did with the previous question, here are the coordinates. The points are original points are the same as before. And those are the points you get after using that transformation. Basically just a half of the value of y. So the value of y there was 0. It remains 0 because half of 0 is 0. 0.3 becomes 1.5. 0.4 becomes 2. The coordinate 0.3 becomes 1.5, and so on and so on. Okay. And there is the last point. The last point was minus 2.5, so it becomes minus 1.25. If we plot those points in blue, every point goes down. So the y value here was 2, so it drops down to 1. Okay. The y value here was 3, so it drops down to 1.5. The y value here is 4, so we expect it to drop down to 2. So every point drops down by half what its original value was, like that. This point remains invariant. 0, half of 0 is still 0. And the other point was negative 2.5, so it must go slightly up to negative 1.5. And again, we simply draw a line through our point. Okay, the last question on this, the last part of question 3. Here is a transformation, and if you're quick enough, if you did this, you should see this is a translation. This tells us that it has moved in the positive direction 1 step and positive x direction 1 step, and that is negative y direction. So effectively every point moves, this point here will move 1 step in the x direction, 1 step in the y direction, like that. This point will move one step in the x direction, one step in the y direction, like that. So every point moves one step, 1, 1, okay, like that. So again, the original coordinates are given. Okay, we can see, so this was -3, so in the x direction it moves in the positive direction, so -3 must move in the positive direction one step, so it becomes -2, and then it moves one step downward, so -1 there. So 0 becomes -1, -3 becomes -2. Okay, the next point there is -2, 3, so -2 moves to -1, 3 moves to 2, like that. Okay, so -1, 2, the next one becomes 0, 3, the next one must become 1 and 2. Okay, moving this way and then one step down. If we look at this, so this becomes 1 and this goes down, becomes 2. So the x-axis is increasing, the y-axis is reducing. Okay, so 0.52 becomes 1.5 and 1. Yeah, and so on the last point, and then what remains is just to plot these coordinate points. And if we do that, similar to what we had done earlier, okay, that is the last point there has moved, and this is the movement of this point, one step that way, one step that way. That is the coordinate point -1. What's that? -2. Where is that? Oh, so this is unfortunately looking at a different value, but in short, this point moves here, this point here moves this way and that way. Okay, this point moves here and ends up there. So we can just look at what's happening in the blue lines, and that's the transformation of the point -1, 4. This is the transformation of the point -2, 3. This would be the transformation of the point -3, 0, moves down, and so on. And then again, all we do is to join the points with a line like that. So this was what was expected out of question number 3. Okay, let's move to question 4. Question 4 was on logarithms. Write down the values of log to base 3 of 81, log to base 2 of 1 over 8, log to base 25 of 5, hence solve that. And of course, to solve this, we are making use of the initial points there. So let's go into it. The first 3 questions, part A of the question, we want to find the log to base 3 of 81. We reason that, so we're looking for base 3. So what we want is to be able to write this under base 3. So 81 can be expressed as 3 power 4. If we see a base 2, we want to express this as 2 power something. Okay, and so let's start with the first one. Log to base 3 of 81, we want to express 81 as being, sorry, that didn't come out clearly, but it's 81 there, is 3 to the power of 4. So we'll replace 81 with 3 power 4, as you know, and then we use a law of logarithms. In our discussion, this was law number 3. You don't have to remember it as law number 3, but if you do, that will just be fine. So law number 3 says that log to any base of a power n, this n just moved to the side, and we proved this with several questions. So that means that we can move the 4 to the side. So we have 4 log to base 3 of 3. Okay? And if we do that, then law number 4, which we also discussed, was that the log to base a of a is 1. And this was arising from the fact that any number, this is coming from the fact that a power 1 is a, And so if you change from index notation to log notation, we say 1 is the log to base this A of that A. Okay? Log to base A of A, like that. And so log to base A of A is 1 when we change from the index notation to logarithmic notation, that way. Okay? And so log to base 3 of 3 disappears, and we are left with 4. So log to base 3 of 81 is simply 4. The next one, part 2, we also want to express this as 2 power something, and if you can see it directly, 1 over 8 is 1 over 2 power 3, which is 2 power minus 3. And so when we substitute that in here, we have log to base 2 of 2 power 3. Again, based on the low number 3, the minus 3 moves to the front, and we have minus 3 log to base 2 of 2. Similarly, using the same laws, where our answer is that log to base 2 of 1 over 8 is negative 3. Okay, part 3 and the last one. This requires law number 6, which was change of base. Log to base 25 of 5 requires, because this is at a higher, this is a larger number, the base is a larger number than the power there. So if we change the base using law number 6, okay, change base, in this case we go for base 5. So usually when you change base, you're allowed to change to any base. This is base 25, so we are going to change this to base 5, and the reason we are doing that is because I can see this is 5. The number that we have there is 5. That is why. Okay, so law 6 says that log to base b of a is just log of a over log of b, and we can decide on what base we want to put here. So right now it's base b. We can't say b and b again here because this will just be 1. So we choose a base according to the question that we have. Now, according to the question we have, this is 5. That allows me to make this base 5 and base 5. So this can now be expressed as log to base 5 of 12. So we must take log of 5 divided by log of 25, and the base we choose is base 5. Okay, if we do that by law number 4, we already know that this one here is 1, and this is 5 squared, so this is 5 power 2, and using law number 3, the 5, the power 2, can go to the side, so it's a half log to base 5 of 5, like that. And log to base 5 of 5 is 1, both in the numerator and denominator. That leaves us with a half there. So log to base 25 of 5 is simply a half. Good. Next, let's solve the equation now. Well, with the knowledge of what these values are, should make life a bit easier now. Log to base 3 of 81 is 4. Log to base 2 of 1 over 8 is negative 3. And log to base 25 of 5 is a half. So if we substitute those in there, we are left with 4 minus 3 plus a half is log to that. This is 3 over 2. I think 4 minus 3 is 1. 1 plus a half is 1.5, which is 3 over 2. It's better to write it as a fraction. Okay. Now we know that. The next is to change base. So this, because we say x is 9 to the power of 3 over 2. And then it is better to split this up so that the half is inside. So you look for the square root before you cube, instead of cubing and then looking for the square root. Because when we cube 9, we get a very large number, and sometimes we are not able to see the square root of that. So it's better to put the half inside so that this is just 3. And 3 squared becomes 27. So the value of x, the solution to our logarithmic equation there is 27. Question 5 on financial math. Okay, on Gary's 50th birthday, he invests $P in an account that pays a nominal annual interest rate of 5% compounded monthly. These are important terms. The amount of money in Gary's account at the end of the year follows a geometric sequence with a common ratio alpha. Find the value of alpha, giving your answer to 4 significant figures. Part B is Gary makes no further deposits or withdrawals from this account. Find the age Gary will be when the amount of money in his account will be double the amount he invested. So we are saying here the amount is going to be 2p because he invested p. All right, so let's start with the first one. Okay, we need to remember this. In the IB, this is usually given in the formula booklet. Normally it doesn't appear like this. I think it says FA for future amount, I think FV for future value, present value, and so on. And in different exam bodies, they use different symbols. And so this AT refers to the future amount, how much the value of the investment is going to be at time t years after today. This is the current amount, which in our case is P. N refers to the number of times the amount is compounded in 1 year. So if we are compounding monthly, then our value of N is 12. All right. And I is the rate, R being the rate. So I is the rate expressed in decimals. So the rate was 5%, and therefore if we divide by 100, we get 0.05. So if we substitute those in, our initial value is P, the value of I is 0.05, and the number of compoundings in 1 year is 12. So if we substitute those in, so after 1 year and after 2 years respectively, the expressions above will become this. So after 1 year, amount after 1 year, principal value into this expression here, power 12 times 1 here, because t is 1. By the way, if this was a depreciation, the formula remains the same, except this becomes negative. Okay, so if the value of something is decreasing. So here is a case where we are investing and we expect the value of our investment to increase. On the other hand, if it was an item or a quantity, something that you've bought, a car, and whose value is diminishing, then the only thing that changes is this. It becomes negative. So this is the amount after 1 year, and that's the amount after 2 years. So if this trend follows a geometric sequence, then by geometric rule, the common ratio is the next value divided by the current value. So A2 divided by A1, or UN plus 1 over UN is the common ratio. So if we work out that quickly, I think that was about 1.05, 117 or 114, something like that. So this is the value to 4 significant figures when you work this out. Okay. Part B, amount doubles after a time t. So after some time t, the amount is now going to be 2p. Okay. The question is to find the time taken for the amount to double. So here is our equation. After some time t, the amount here will have doubled. So it will have become 2p when the initial amount is p. All right, the rest of the parts remain the same. If we put that in from the formula, we get that. And remember, from the previous part, this bracket to the power of 12 is 1.051. It was the common ratio. So we could have written this as alpha power t, where alpha is the common ratio. Okay, and so 2p must be equal to p times. So there is something missing here. This is supposed to be p right there. So p times that. Yeah. So dividing both sides by p. So there is a p here. So that when we divide both sides by p, this cancels with that, and 2 equals 1.05. So what I'm saying is there is a p here. There is times p there. Okay. So that if we cancel both sides, I might as well write this here. So what we're ending up with here is 2p equals p into 1.051 power t. So if we divide both sides by p and simplify, we have 2 equals 1.051 power t. Change that into logs. We get t is log to base 1.051 power of 2, and that is 13.89, which is approximately 14 years. So it takes 14 years for the amount to double. But the question is, how old is the guy? How old is Gary when the investment doubles? Well, Gary is going to be 50, which was his age, plus this, which is therefore going to be 64 approximately. Okay? He will be 64 years old when his investment doubles. Question 6, sequences and series. This was a simple question on sequences and series. Basically, an arithmetic sequence or arithmetic progression says in arithmetic sequence, the fourth term is 12 and the 11th term is -9. Find the common difference, the first term, and the sum of the first 11 terms in the sequence. Okay? So, first of all, the information given to us, U4 and U11 are given. We are looking for, before I go on, I decided to do a quick derivation to find a much faster formula than just the standard formula. Okay, so for some known n and m that are counting numbers, natural numbers, where n is greater than m, we know that un is u1 plus n minus 1d, right? So this is something that we know. So this could be, say, the 10th term is u1 plus d into 10 minus 1. The 20th term would be u1 plus d into 20 minus 1, like that. So the mth term must be u1 plus d into m minus 1, and so on. So another term there, m, is given by the same, right? So if we subtract this, subtract equation 2 from equation 1, then un minus um must be this minus this, which disappears, and dn, so I could simplify this. This here is the same as dn minus d. And this here must be the same as, this here must be the same as dm minus d. So keeping that in mind, we are saying we're going to subtract. So un minus um must be equal to u1 minus u1, and the top there we have plus dn minus d minus dm minus d. This is the same as un minus um equals this cancel, and this also cancel, because this is going to be minus, that can disappear. If I open the bracket, this becomes minus dm but plus d. So d and that d cancels, and so we end up with dn minus dm, which I can write as d into n minus m, right? And so the rest is there. We can now write un equals um, because this goes to this side, and then we say plus d into n minus m. Remember, n is greater than m. Okay, so this is a result that becomes much faster to use than going only with the standard formula that we've used before, like this one here. Okay. there is, and I think we derived that, a similar equation for geometric series. We derived a similar equation so that when you're given two terms like this, then it is possible to find the common difference and the first term faster. In the other case, the common ratio and the first term we can find much faster. So here we go. I left this space here so that I would use it for what I've just done, so therefore un minus um becomes dn minus dm. Factorize the left hand side and move over the on the other side, and we come up with that. So this result is a much more useful result when you are given two known terms which are separated, and you're looking for the common difference and the first term. Okay, so with that in mind, now we can go ahead and answer the questions. I will move this over to the other side. And let's start. We are looking for the common difference. So if we use that formula there, from that result, we get the U11. So n is greater than m. Our n now is 11, and our m is 4. So we are talking U11 equals U4 into plus d into 11 minus 4. Straight away, if we do that, we have that negative 9, which is U11, must be equal to 12 plus 7d. 11 minus 4 is 7 there. Okay, you can slow down or pause the video to check that this is correct. And if you rearrange, we have there negative 21 is 7d, meaning that d is going to be negative 3. Okay, part B of the question is to find the first term. Well, now we know the value of the common difference as negative 3. Okay, so if we substitute in those values there, we are using U4 there. We are using the standard result and using our U4 there. So U4 must be U1 into D into 4 minus 1. We know D is negative 3. We just found it in part A. If we substitute back there, 12 is U1, and this is minus 3 times 3 is negative 9. All right. And so move that to the other side. We see that U1 is 21. Part C, the sum of the first 11 terms in the sequence. Sum of the first 11 terms of the sequence. So we use the formula for the sum of a sequence of an AP. The sum of an AP is given by that formula there, S for sum, N for the number of terms you are adding. So we are adding 11 terms, N is 11. We know our value of U1, we just found it as 21. And we know our value of D, we found that as negative 3. N is 11. So therefore, the 11th term is 11 over 2 into 2 times U1, like that. And when we simplify that, we get the sum of 11 terms as 66. Okay, not very bad. The last question is number 7. This was straightforward. If you remember, this question was actually put here just to remind you of the stuff you did earlier, so you do not forget as time progresses. Yeah. This is coordinate geometry, equation of a straight line, gradients and intercepts and so on. The straight line L1 has the equation y is a third x minus 5. Write down the value, the y-intercept of L1 and the gradient of L1. Okay. The line L2 is perpendicular to L1 and passes through the point A is 2, 4. Find the gradient of line 2. Find the equation of line 2, giving your answer in the form ax plus by plus d equals 0, where a, b, d are integers. Okay, so let's go ahead and answer this question. It's just a reminder, this was simply remembering a few facts. Hardly any mathematics here. The straight line L1 has this, so this is the first part. Write down the value of the y-intercept and of the gradient. This we just do by looking at this. And what do we need to remember here? What we need to remember is that the general equation of a straight line is given by y is mx plus c, where m there is the gradient and c is the y-intercept. So if we compare that with our equation here, we can straight away see that the coefficient of x is the gradient, that's a third, and the value of c is the y-intercept, which is -5 there. So that is just, that's not math. The y-intercept is -5, the gradient is a half. Excuse. Okay, the straight line L has the equation y is that. The line 2 is perpendicular to line 1 and passes through that point. Find the gradient of line 2. Okay, now this is important to me and it's important for you going into DP, or if you're already in the DP, this is important. What information do we need to remember? We need to know that for two lines that are parallel, if two lines are parallel, L1 and L2 are parallel, then their gradients must be the same. If the two lines are perpendicular, then the product of their gradient is -1. Another way to say this is that the gradient of one is the negative reciprocal of the gradient of the other. So I could write this as m1 here. I could write m1 equals -1 over m2. So the gradient of one is the negative reciprocal of the gradient of the other line. So these are extremely useful, and they're going to be useful in calculus as well, okay, when we look for the gradient of tangents to curves. So we need to remember this. Find the gradient of L2. So because L1 has a because L1 and L2 are perpendicular, and this is L1, L2, the gradient of L2 has to be the negative reciprocal of this. But showing it mathematically, we'll use that formula there. Before I do that, I believe maybe we can do it after that to demonstrate that perpendicular lines, the gradients are negative reciprocals of one another. So M1 is known. So by that second rule there, the product of the gradients must be -1. So a third, which is the gradient of the first line, times the gradient of the second line must be -1. So clearly M2 is going to be -3. Okay? Here's part C. Find the equation of line 2. So we know the gradient. Okay? We know the gradient. Here is a relationship that is faster to use in this kind of questions. Remember, in the exam, you would have a very few minutes to complete the, 1.5 hours to complete 10 questions or 13 questions. So the faster you can move, the better. So this actually comes from the equation of the gradient of a line, which is m is y2 minus y1 over x2 minus x1. This is where this formula actually comes from. You can see if I rearrange this, I would get, if I cross multiply, I get y2 minus y1 equals m into x2 minus x1. So if we know the coordinates of one of the points, such as 2, 4, that would be this. So that's the y coordinate 4 there, and this is the x coordinate, which is 2. So if we write it like this instead, and then this just becomes the variables, x and y here become the variable. So when we write it like this, we can find the equation of a straight line much faster than trying to look for the gradient first, then trying to substitute to get the value of c, the y-intercept, and then rearranging again to the form that is being asked for. So in this case, it becomes a little faster. So we know the gradient of line 2. Okay, so using that relationship, and we know the coordinates of the point through which line 2 is passing. Okay, with that information, we substitute into this formula. So y minus 4, which is the value of y there, the value of the intercept for y, and that's for x, so x minus 3. So y minus 4 equals -3, which is the gradient, into x minus 2. When we rearrange that, we get 3x plus y minus 10 equals 0. You can do this a bit slower and see that it is true. This here is y minus 4 equals negative 3x there, and we can see that is plus 6. So if 6 goes to the other side, it becomes minus 6, and that is negative 10. So, and 3x, negative 3x also goes to the other side, so it becomes positive 3x. That's not very nice. So positive 3x, well, it is what you see on the screen there. If we move this to the other side, it's positive 3x. Move this to the other side, minus 6 minus 4 is minus 10 here, and positive y remains there. So this is the result, what we end up with. Yeah, that's really it. The next bit is consolidation on a transformation. We will look at this in another video. Thank you very much. See you later.